And we're live. No attendees yet, chaps.
No.
Well, I guess nobody was waiting.
We're right at the top of the hour, so I think some people are coming in now. If you have joined us, we're just letting a few people come in, so we'll just let the numbers go up a bit more, and then we'll be starting.
I hope you're all excited.
As excited as we are.
Exactly.
How many people we got, chaps?
We
I
have
can
3 attendees.
3 so far.
give everyone a minute or two. So thanks for the early joiners. We really want you to use the chat as much as you can through this. We've got a few slides prepared just to try and start everything off. But the whole point of this session is that you're going to interact with us, ask us questions, and we'll do our best to answer them as we can. So we'll explain in a minute or two what we specialise in, so hopefully you know what to ask us. But ask us anything, and if we can, we'll answer it. If not, we'll do our best to find the answer.
If you've got a really hard question, direct it to Richard's direction, if you don't mind. And he can answer those tough ones.
And I'll ask Spencer.
Then we'll create a ticket.
Yeah. Got a few more people coming in, and then we'll get started. So
My Zoom went really fun.
for those of you that probably don't know,
I'll have to leave and join. Sorry, guys, give me a second. I can't see the video anymore.
While Paolo's doing that, so the 3 of us are all actually in the same team. We're called the process specialists. So we effectively work mainly on Fusion 360, but we've also got a background in a lot of other products as well. And our role is really to hopefully know the product inside out and work in conjunction with customers to try and help them get the most out of the software, really. We're part of an organisation called the Customer Advocacy organisation. So we are heavily customer focused, spend a lot of our time speaking to people. We are on the forums regularly, and myself, Spencer and Paolo also do live streams most Thursdays. Although we're not doing it today, obviously, because we're here with all you lovely people. So
YouTube live stream, right?
Yeah, YouTube live streams, good point. That's what we are on that. So, okay.
I need to start my video, and it's saying that the host has stopped my video.
1 second.
Yep. Just so they can see my face. It's not like they would miss out if
I did it on purpose, Paolo.
Yeah, I know. I'm sure. Is it because of the face, or is it because of something else?
A few of you might realise Paolo's accent is slightly different to mine and Spencer's. So myself,
I'll tell them why. Probably the name as well should give away the fact that they're British, but.
So myself and Spencer are in the UK based. We are, effectively we used to work out of the Birmingham office until it's shut down for our work from home period at the moment. I'm based in a little town called Halesowen, west of Birmingham, and Spencer is right up north.
Yeah. A place near a place called Leeds, which isn't too far away from Manchester. For those international viewers, you probably know where Manchester is, so not too far away from there. And then Paolo is in Italy.
Whilst I'm based in Italy after 6 years, well, let's say 5 years in the Birmingham office, and obviously, as they said, in the same team, I moved back home. I'm based in Rome. I'm a remote worker. Well, let's say we all are now, but I used to be a remote worker even before the big pandemic problem started. So what you see in the background, unfortunately, is not where I am at the moment. But I do live on the seaside of Rome. So
you're living a lie with that background, Paolo. You need to come back down to earth like Richard has with his.
Yeah, well,
All right, chaps, it's 1:05. Shall we kick it off?
Yeah,
Let's kick it off.
So, as Rich said earlier, thanks everyone for joining. This is an Ask the Expert or so-called expert session aimed at maximizing your Fusion 360 experience. So, use the chat, use the Q&A. We'll be manning those areas. We'll be answering all questions, any questions related to anything Fusion 360 related. In particular, the manufacturing side, and we'll come to those questions as they come in. Let's start with a little bit of an introduction as to who we have on the call. So, my name's Spencer Hardcastle, as we've already said. I'm based in the north of the UK. I started Delcam through the acquisition. Sorry, I started Autodesk through the acquisition of Delcam all those years ago. So I've worked for Delcam and Autodesk for the past 6 years. I started as a graduate alongside Paolo. It seems like a long time ago now, but we started off as graduates in Delcam, doing a rotation scheme around various departments, learning our trade, if you will, and eventually landed a job as an applications engineer in international support, specializing in products such as FeatureCAM and a few others along the way. And now I work as we all do, as process specialists in the Customer Advocacy organization, looking at Fusion 360 and in particular, trying to really bridge the gap between the customers and the product development teams and product management to ensure really that everything that's going in the software and the direction of the software is a true reflection of what the customer wants and what the customer needs. And like I already said, we all specialize in our own little areas. And so I'll pass it over to Richard just to give a little bit of background to him and his career so far.
Yeah, cheers, Spence. So I'm slightly different to the others. Rather than study in a classroom, I studied in a very dark and dingy forge originally. So back in 2010, I left college, went to work for a forging company that had, I think, 24 employees, so quite a small place really, but gave me quite a good understanding of the engineering world and forging, of course. This is where I first was introduced to Autodesk before I knew really what they were with the Inventor software package that I used to do designing of the mold and die tools with. So I've always worked in quality control, but loved CNC machines. I put passion/fascination there, because anyone who knows me knows I do tend to get quite emotional about things I should probably just be a bit more methodical about. So I started to work at Autodesk 4 years ago on the product called PowerInspect, and then now with Spencer and Paolo, I spend most of my time specialising in Fusion, mainly on the metrology side of things, but can't escape subtractive machines and design world as well. So that's where I spend a lot of my time doing that really. So yeah, that's a little bit about me.
Thanks, Richard. Really interesting background there. I'm sure some people have some questions for you later on, I'm sure. Pass it over to Paolo, a little bit of a background on you.
Yeah, saving the best for last. But it's not, let's say my background is not that dissimilar from Spencer's. As he mentioned, we pretty much joined together. So I joined Delcam in 2014. Subsequently, obviously, we were acquired by Autodesk. So I've been working for Delcam, let's say, / Autodesk for, I'm just coming up to 6 years, and I think Spencer as well, of course. So I think we're about a week away from our 6th anniversary. I've worked in several roles. Again, I joined the graduate scheme after graduating at the University of Manchester. I was already in England. For those of you wondering why an Italian ended up in Birmingham working for a CAD/CAM company like Delcam, I studied in Manchester for my master's degree and then just moved a couple of hours south. Landed a job in Birmingham, as I said, graduate scheme first, then started working as an applications engineer in the international support department, mainly focusing on PowerMill and at the time, and then NetFab. We then, obviously, with the reorganization, we ended up concentrating really our focus on Fusion 360. And that's the my current role as the other guys on the call. I'm a process specialist in the Customer Advocacy organization, mainly focusing on Fusion, a bit less on the inspection side. Richard, a bit more on the subtractive side of things. Okay, so that's a little bit of background. If you have any questions at any point, just drop them into the chat and we'll do our best to respond.
Absolutely. The purpose of this session is for you out there to ask any questions you want regarding Fusion 360, and we'll do our best to answer them. So please, as we said in the chat, use the Q&A section for this. And there's 3 of us, so at least one of us will be able to man that dialogue and get to the questions as soon as you can. But to inspire a little bit of Q&A, a little bit of back and forth, Paolo is going to take us through a bit of a workflow combining a couple of products, combining Fusion 360 with PowerMill. So over to you, Paolo.
Yeah. So as I said, this is just to spark a little bit of a conversation. If any of the questions you have are completely unrelated to what I'm talking about, I'm more than happy as well. No, the questions you have do not have to link necessarily to what I'm going to talk about.
Your questions take priority, we'll just stop.
Exactly. I'll just shut up and answer any questions you have. But yeah, so as I said, a little bit of a workflow linking Fusion 360 and PowerMill here. You probably have heard of generative design within Fusion 360. If you haven't, I don't know if you've been living in a cave or under a rock, but really it's all over the place. It's going to change the way we design and make things in the very short term future. Generative design is a technology that kind of mimics nature, okay, and how things evolve in nature. What we start is with the user setting, pretty much creating a problem statement, okay, saying, okay, what is the thing I need? Okay, am I going to design a chair? Am I going to design a bracket? Am I going to design, I don't know, a mold or whatever else? And then the user has the option to tell the software what material he wants to use and what manufacturing method he wants to use. So say I want to machine this thing in. I've got the option of titanium, I don't know, Inconel, brass, aluminum, whatever else, but I really want to do it with milling, for example. I really want to do it on a milling machine. And on top of that, we need to define what the performance criteria are. Again, if it's a chair, really, it only needs to withstand the weight of a person. While if it's a bracket, it may have some mechanical requirements, some physical requirements it needs to meet. Okay. Once we set those, the software will automatically generate and present us with a number of designs that we're guaranteed will satisfy the mechanical requirements we have set, including a factor of safety, which, as you probably know, in engineering is quite an important aspect. And each solution that the software will output will not only guarantee the requirements are met, but also the performance criteria that we define, the manufacturing method and the material requirements. All results, all outputs can be looked at in real time versus their requirements and versus their performance data. And then it's free for the user. Well, it's not free in terms of free of charge, but the user is free to output the design for any minor or even major design modifications. So we don't have to take what comes out of generative design as, okay, this is the design. We can take it out, modify it ourselves, just use it as an inspiration, really. Okay. Sometimes with generative design, depending on the manufacturing method you choose, now we have, you can choose whether you want to machine it in 2 axis, 2.5 axis, 3 axis, 5 axis, whether you want to additively manufacture it, and so on. So in some cases, for simple 2-axis parts, the part may end up heavier than a 3-axis part or than a 5-axis part. Obviously, when we tell the software, I've got a 5-axis machine, just get rid of as much material as you physically can, so reduce the mass as much as you want as my objective. then the software will just get rid of as much material as you want, but the part itself will look like organic, freeform, kind of alien in a way. So if you want to go to the next slide, Spence. Thank you. So if we look at the part like a part like the one you can see on the right hand side of the screen, that looks quite freeform. There are some areas that are, you know, machinable quite easily in 2 axes, but some areas are really not machinable in 2 axes. It's a very organic shape, very freeform, and this is where PowerMill comes in to help. For those of you that don't know PowerMill, PowerMill is a high-end expert CAM package that includes a vast library of roughing and finishing strategies. It's really marketed at those users that need to machine complex parts, okay? So what is this gonna give you? If you pair generative design with PowerMill and with this, basically with a greater choice of toolpaths, with more flexibility, more efficiency when machining your parts, you really end up with a toolbox that includes some, you know, advanced tool axis control, full 5-axis collision avoidance, and a series of other expert tools within the software will make sure that you can machine complex parts in a much easier and much more efficient manner. So if we want to look at how the 2 software really combine and really work together, there's a little video, just less than 2 minutes long, I promise, nothing too boring. If you want to go to the next slide, Spence. Really what we're machining here, what we're going to redesign is an automotive upright, the one that you see in blue. In generative design, you've got to set up your where you want the material to stay, where you're happy to get rid of material, what your loads are, what sort of machining configuration you want. As I said before, 3, 5 axis. You got to pick your material. Obviously, in this case, we may want to look at multiple materials. You know, I'm happy with aluminum, I'm happy with titanium, and so on. And then all you need to do is click Generate Study, and the software will automatically spit out all of these outcomes, all of these solutions that are, you know, all going to meet the manufacturing requirements. Oh, when do okay, they're all going to meet the manufacturing requirements. They're all going to be available for the user to look at individually. Oh, and again, okay, let's play that.
Apologies, technical difficulty.
There we go. All of them with their manufacturing requirements, all of them with their weight, volume, and all physical properties that you may need. The software will allow you, as you expect, to output the part. And now we look at PowerMill, okay? A complex shape like that in Fusion, I mean, I'm not saying you cannot do it, but you'll probably struggle a little bit with the current functionality. Don't worry, we're catching up, but with the current functionality, we can't. If you've seen PowerMill, full machine simulation, full 5-axis control, automatic collision avoidance. Now, to give you a little bit of a better link between the 2 software, we have just implemented automatic collision avoidance within Fusion 360 just for steep and shallow. For those of you familiar with PowerMill, you may remember steep and shallow as one of the flagship toolpaths within PowerMill. We've implemented the in Fusion as well. We have included automatic 5-axis collision avoidance for that. But again, in PowerMill, you're probably looking at doing it in a bit more of an easier and a more intuitive manner. Now you can also see the actual machining of this. Everyone loves some machining footage, some coolant and some swarf flying off. But just to give you a bit more of a background, we have actually machined that component in the Birmingham Technology Center. So we're not just talking about, you know, in software, we've actually machined the component. We've actually evaluated the physical requirements of the component and realized how much lighter than the original upright it was. Okay, I promise I'm going to shut up now. I spoke way too long. I'm going to leave you in the other guy's capable hands, and I'm going to make sure. Do we have any questions about this in the chat or?
No questions about this, Paolo. Thanks so much. That was a really interesting workflow there, combining those 2 technologies. We have another question about tool libraries.
Okay.
In particular, turning tool library functionality, Dave wants to know if you can create custom turning tools like you can.
I'll stop typing my reply and might as well say it now. So as far as the custom tool holders go, I know that is being actively worked on. So that is in the pipeline to come along. The same with custom milling tool holders and custom turning tool holders. That is definitely something that is on our roadmap and we want to implement. As far as form type for turning tools, that's not something that I've seen on a roadmap or seen requested before, but I'll definitely put it to the product manager who's in charge of turning, because I don't know if any of you out there sort of know, but the way we really try and develop Fusion is what people ask for. So if enough people ask for something, it hopefully gets done. That's what our product management team are all about. And myself, Spencer and Paolo in the Customer Advocacy, our job is to basically be the little workers and go out and collect all the information and present that back to the product managers for them then to make the decision on what they want to do. So effectively what you've just done is put a tick in or a tally in on a post-it note on his wall that goes custom form type turning tools. And if enough tallies go on that post-it note, then it will get done hopefully. So I know that the custom tool holders is being worked on because loads of people have asked for that. I will definitely put your feedback forward about a form type turning tool. I don't even know how, I've never seen a custom tool, but I'm not a turning expert, so I wouldn't even like to guess on that. But yeah, so if any of you wonder sort of, is there a big black hole these go into? No, we pass them on to the relevant product managers. And, unfortunately, if one person asks for something and 300 people ask for something else, will you guess what's going to get developed first? But we do really try and develop Fusion with requests rather than just what we feel like you need. So thanks very much. And we'll carry on then. I believe Spence is next.
Brilliant. Yeah, over to me. Thanks very much. So Paolo's looked at a workflow there combining two products. It was PowerMill and it was Fusion 360. And now I'll take us through a little bit of an example, again, just to spark a little bit of conversation and Q&A surrounding the combination of the Fusion 360 product with FeatureCAM. And so one of the main benefits of Fusion 360 is its ability to bring different teams within the design and manufacturing process together in a collaborative manner. And what I mean by that is allowing you not only to share your data in the cloud and access from anywhere and any device in any location, but also to comment, mark up and share your designs without the need to actually install the software. So we have a client that runs in the background that controls our data system called Fusion Team, which can be accessed from a browser. And for those that have used Fusion before, the 9-box icon, top left-hand corner that brings all your data up. In the background, that's Fusion Team as well. And like I said, what it does is it allows you to manage your design process, allows you to collaborate with different teams. So now the shop floor is intertwined with the manufacturing departments, and the manufacturing departments can be linked into sales. And by linking all these teams together, it allows you to really increase your efficiency and productivity when it comes to the design and manufacturing process. So like I said, you can share your designs, you can review them, you can manage versions on there, so it's got version control. We semi-recently added milestones so that you can tag key saves so that we know exactly what's going on at exactly every stage of the design process. And then, of course, because we're storing all this data in the cloud, you've also got distributed design functionality, which allows you to bring in other designs and other models and Fusion files together into one big assembly file, I guess, if you will. And so what we have then is a situation where you can link files together. You can have used in or used by tags. So now everything gets updated automatically. So perfect example of this might be a vice. So in one of your files, you're going to go ahead and design a vise or a fixture or some sort of work holding. You might bring that into 5, 6, 7, 8 different manufacturing parts or parts that you want to create an accurate simulation for. If you then update, yeah, sorry, Rich, go ahead.
Can I just interrupt you for a second with a question?
Of course you can.
Cool.
It's a great question, and it needs to be answered.
Yeah. So I'll answer it. Don't worry, I'm not going to ask you to answer it, but I didn't want it to hang on for too long. So
No,
Justin's asked a really good question. So for those of you that haven't seen it, Justin said a big picture question. I watched a video today describing the plan for the ultimate breadth for Fusion 360, encompassing just about everything that Autodesk can do. I'd also say, and everything we want to do as well. My question is, will it step into direct control of CNC machines? Currently, we do all the work, output a file, load it onto the machine. Are there any plans to hook up directly the PC to the controller and control the machine this way? Well, yes is the answer, yes. But it's not an easy yes. So without boring everyone on this call, so there's the way I talk about this is when we post an NC file, I call that a static file. It is a text file that isn't going to change, is just going to run through top to bottom and hopefully make you a good part at the end. With some of the probing stuff, which I can happily talk about later if anyone wants to know more, we're starting to put decisions in this. So we could sort of say, is this part correct? If not, then do this and update toolware and do that. The problem with getting rid of NC code and directly controlling the machine tool is speeds. You know, even with an Ethernet cable, can we send the data quick enough to the machine for it to process? What happens if that connection gets interrupted or severed? You know, some of these machines and some of these parts are so expensive, you can't afford for that to happen because they can crash, or you could get a dwell mark on the part. Some of the aerospace we do, you get a dwell mark on the part if you stop and then the parts scrap. So that's a big sort of stumbling block about getting rid of NC code and us directly controlling the motors themselves. But what we're looking at doing, which is probably going to be our interim step, is hiding the NC code sort of from yourselves, from the users. So you connect directly to the machine. We then actually send the NC code over and it runs. But you just don't realize that it's the NC code and the post processors around it that are actually running in the traditional manner, but in a more automated way. But controlling machines directly is something we are definitely looking at doing. But it's going to not only involve a lot of work from Autodesk, but also machine tool vendors and the builders are going to have to drastically change the way they build machines, which then you can imagine instantly means that there's no backwards compatibility with older machines. So you can imagine it is on our radar. It's something that we really think needs to happen in industry.
It's a conceptual change. That's the thing. It's a change of the way the current technology works. So it's, you know, we probably use the word disruptive way too much, but this is like the definition of disruptive. Like whatever happened before the day we actually get to this functionality is going to be wiped out completely, meaning not just us, but the industry has got to, in inverted commas, be ready for it. And as Richard mentioned, the machine tool vendors, the machine tool partners, will have to get as excited as we are about this to actually get this done at some point. Don't expect this in the next months. That's obvious.
I'd say years, but
yeah, exactly.
Yeah, but you know, I mean, but we're working on solutions ourselves at the moment to more. I don't want to say proof of concept, but for example, one thing that I'm working on with my development teams is when we inspect to have a live connection to the machine. So those inspection results come back into Fusion in real time, and then we can stop the machine if anything's out of tolerance. So we are actively working on sort of halfway grounds, between the current way of doing things and where we want to be, because where we want to be is so far ahead of what we can do. We know that we need to do something in the now. And that's what we can do as a software provider without having to have the machine tool builders dramatically redefine how they control their own machines. But don't get me wrong, can't really say who they are, but we're having conversations with multiple machine tool vendors about these exact concepts and how do we do it. And also, how do we provide a standard for this? Because the last thing we want is every machine tool to be driven differently, and it's an absolute nightmare to work out if your machine's supported. So, it's bad enough now with post processors to try and work out, have I got a post that works? Have I not got a post that works? Imagine if we are directly controlling those motors, it's going to be a nightmare. So, yes is the question. It's on the map. Can't give you much information about it, but we'll probably have software solutions to this in the interim before we can go down to directly controlling the controller motors and actuators and everything themselves directly from Fusion. I hope that sort of answered your question. It's probably as much information as we can give, not only because we can't really say everything, but we're still working on this conceptually as well. Please say if you want any more information and we'll tell you what we can.
Thanks, Rich. I think that was,
sorry, Spence.
No problem at all. I think that was a really good reason to cut me off mid-sentence, and really good. No, I'm only kidding. It was a really good question and a really detailed answer. So I think it lines in what we were saying as well. It's distributed design functionality where you've got these multiple designs all linked together. So you go back 10 years, no one was storing data in the cloud and being able to pass that from person to person, or being able to collaborate in this way. And so we've done it with the designs. We've done it with the attaching designs together. It would only suggest that the next step and the next area to tackle would be those NC files. So watch this space, like the chap said, for sure. So that was a little bit of background on Fusion Team. Thanks, Justin, for the question. This workflow we're talking about now is linking Fusion Team to PowerMill. FeatureCAM. And so then on the FeatureCAM side, for those that haven't used it, it's a feature-based programming software aimed at production run parts. And on FeatureCAM, we've got full machine simulation and the ability to be able to embed your machine's capabilities virtually, which allows you to improve your safety and your programming confidence by confirming that the parts aren't going to collide, there's no collisions, and that you avoid any unplanned downtime on the machine as a result of these possible collisions. And so it allows us to verify your parts for things like collisions and near misses, of course, and identify problem areas early before we actually send to the machine. Machine time is money, software time not so much. And so this allows you to then adjust your work holding, maybe use alternative tooling, and really gives you an insight into the machining interface before actually sending any code to the machine. So let's take a look at a simple workflow. We start in Fusion, and then we've got a part file. And like I said before, we're just going to insert our work holding. In this case, it's a wrapped device. We're happy with its location. Or it's, the way it's come in, but now we just need to position it in the correct place. Again, just to give us an accurate representation of our machining experience. So I'm going to utilize some of the assembly capabilities inside Fusion just to position those jaws exactly on the edges of that part. At this point, I'm going to export from Fusion as an F3D. Now, the F3Ds can be pulled directly into FeatureCAM, so there's no need to use a step file or anything like that. And so here's my part in FeatureCAM, and the first thing I'm going to do is I'm just going to create some setups, one on each side of the part. When I say each side, top, left, and right. And the reason why I'm doing this early on without programming any toolpaths first is I'm going to utilize the automatic feature recognition capabilities, which will allow me to recognize features on all three of these setups in one wizard. So there you go. It's what happens At this point, is it's recognized all of these features, series of holes, series of side features, and it allows you to deselect any that you don't want to program. And so in this case, I've deselected the run around the outside of the part for a couple of reasons. One is we're going to face off on each side anyway. And the second is, obviously, if we run around the outside of this part, we're going to collide with our jaws. So again, move over to setup 2, choose the relevant features, and finally setup number 3. And again, just deactivating the unnecessary features. And at this point, we can go ahead and press finish. And so as you can see, it's automatically added all our features in there. Last thing I need to do is just add our solids as fixtures, or as clamps, they call it in FeatureCAM. This will allow us, when we run our simulation, to also include those solids and to collision check against those. And so now you can see we're running this full machine simulation, making sure that all of the parts machining in a safe and an efficient way. And all of a sudden, as we rotate our part to perform the second setup, you can see we're running into a bit of a collision. So I'm rotating the view, just seeing where that collision is. And as you can see, it's a collision between the head and the table. So now let's fire up Fusion Team. This is in a browser. You don't need any software to do this. So the FeatureCAM user can jump on the browser and he's going to go ahead and add a comment. This comment is, can we add a bit of a riser plate? Because what we want to do is actually move this part away from the machining table in order for our head to have enough clearance to machine those features that you see on the side. So again, I'm going to, instead of designing one from scratch, I'm just going to bring one in, position it to the correct location, and again, export this as a Ref3D. Now, when we go back to the FeatureCAM side, we can just replace the F3D and all of our features will still stay there. We'll just get this added riser plate on the bottom of the component. So again, we'll run another full machine simulation. Let's go ahead and zoom in through those lovely machine doors. And you can see we're simulating all the features again on the top of the component, just as we did before. No real change to this particular setup. But as you can see, as we rotate to setup 2 and setup 3, we're now collision free. And so at this point, I can go ahead and save my NC code, transfer it over to the machine, and I'm significantly more confident that this is going to run on the machine first time collision free. And so again, that was just a bit of a workflow. I don't want to see it again. That goes through a combination of Fusion 360 alongside FeatureCAM. And of course, these two programs are available and are purchased now together. And so by purchasing one of these, you're benefiting from both. And it's not just FeatureCAM and Fusion you can benefit from, but you can also benefit from PartMaker and of course InventorCAM as well. So that was just a little bit of inspiration, I guess, to try and tease out some questions. How are we looking on the Q&A, chaps?
We have a feature.
Dave's got a FeatureCAM one, Spence, so I'm leaving that one to you.
He says, is that replacing FeatureCAM automatic based on the file name of the F3D file?
Yes. So in FeatureCAM, any solid model that you bring in has a reference location. If that reference location is updated in any way and has exactly the same name as it did before, then it will give you an out of date symbol. You can go ahead and re-import that into FeatureCAM. And like I said, all it's going to do is it's going to update your solid models, leave all your toolpaths exactly how they were before. So I hope that answered the question. If it doesn't, hit us up in the chat or ask another question in the Q&A.
They're exactly with the answer.
Perfect. Perfect. Thanks for the question, Dave.
And that look like off topic doesn't matter. There's no topic.
No topic. Yeah.
Ask Paolo what his favorite pizza is, and it'll be barbecue chicken. And yeah.
That's a bit very off topic, both for the question and the answer.
Sorry.
Brilliant. Keep those questions coming in. Thanks, Dave. Thanks, Justin, so far for the questions. Like we said already, nothing's off topic.
I'm just going to grab one here from Hans. So are there any plans to add more control over generative design outcomes in Fusion 360? Maximizing surface area for heat sinks, using symmetry, So, for example, the symmetry one's an easy one. I
Yeah.
don't know when the last time you used Generative Design is, but there is now in the browser, there's actually a symmetry plane, and you can put construction planes in and say, I want symmetry about these planes. So that is really nice.
It was an easy win, really, that one, because many people were saying you actually have it in Inventor. Can you please put it in Fusion as well? We were like, yeah, but it's a bit different. You know, it took us some time, but in the end, we got there.
Yeah. For wheels, you more need rotational symmetry than you need sort of planar symmetry, which is what we're doing at the moment. So what I would do for a wheel is actually just do, let's say it's a 5-spoke wheel, just go for 1 spoke, put some obstacle geometry on the sides, still model that center hub, and then pattern those spokes round as I need to. But I did a bike pedal the other day in Generative, and I used exactly that. Used a symmetry plane along the X and the Z to make sure that sort of the 4 quadrants were identical. So yeah, symmetry's in there. I haven't heard about one for surface area, but I'll definitely pass that feedback on. Sounds like a really viable solution there. You want a heat sink? You want it to...
Yeah, that's quite. It's quite topical as well, because in August we've just released better support for heat sinks in simulation.
What load would you put on a heat sink, though?
Huh?
What load would you put on a heat sink? Because Generative is all about.
Yeah, but it's probably, rather than load, it's probably about putting it. Well, that's why I'm figuring it is having the heatsink there, not get rid of material or add material on it. It's just it is there, part of a bigger picture.
So that's really interesting though, because that's a completely different application of Generative to do something like that, and it's going to be possible with the algorithms we've got. But yeah, no, I'll definitely pass that on. Thanks, Hans. That's a brilliant thought there on that, because we can use the algorithm to look at maximizing the surface area rather than a stiffness target. So,
exactly.
Come on, keep the questions coming, everyone. I mean, I'm not wanting to sort of put onus on you, but this session is only really going to be as good as you guys make it. So keep these questions coming. Spence is like, don't insult the audience.
No, yeah, Rich is absolutely right. Let's hear those questions. Let's make some tough ones for Rich. Maybe like something to do with probing or metrology for Rich. Or
OMV.
Let's tackle some of the extension toolpaths. And for me, let's just talk about facing. I'm an expert. Right? I'll tackle all of those and leave all the tough questions to the other.
Okay, so Spencer, when you're facing, what parameters would you use? Stock offset versus pass extension, and why?
Well, it's a very interesting question. Path extension only goes in the direction that the tool is going, right?
Yeah, so what value would you put in there?
What value would I put in there? Well, I think it's all related, of course, to your tool diameter, right?
Oh, damn. I wanted to catch you out, but yeah, bang on. Tool.
Oh, yeah, expert in facing.
Yeah. In all fairness, I don't know if any of you know, but most of the dialogues in Fusion are expressions. So, for example, on what I do on my facing one, I've got a little expression in there. So where it goes pass extension, right click and go edit expression. And I do tool diameter times 0.6. So call it its diameter. You want to convert it into radius. So that would be 0.5. I like to be safe rather than sorry. Add a little bit more, times it by 0.6. There you go. Perfect. But I tried to catch Spence out, but he's an expert in facing.
Oh, yeah. So we've got no more questions coming in, I guess, right now. So I'll pass over to Rich, who's going to give us a little bit of inspiration for questions surrounding Fusion 260 in conjunction.
15 minutes, Richard. I think we have to be, me and Spence took a little bit longer than we thought. We really saw.
Yeah. No, I can talk for 15 minutes or 15 hours on probing, so we can go for that. So I want to know in the chat how many of you 15 lovely people out there have got probes on your machines and use them, or how many of you are making parts and have to inspect them, and I will change the way that I do things. But we've quickly got a question from Dave again. Can you run through the process of setting up the required templates to use in the whole recognition extension? Probably can't in 15 minutes, but is there a video we can forward on anywhere, do you know?
I'll take a look.
So I'll let Paolo grab a video of that and we'll chuck that back in the chat. We probably can't go over that in the 15 minutes we've got left, but we should have some content we can pass on, Dave. So
we can definitely talk through it real quick. I don't mind taking this one. So hole recognition that's available in manufacturing extension is technology that you might, if you've used FeatureCAM before, you might recognize. And so the idea behind the hole recognition is to do multiple sizes and multiple types of holes all in one click and in one process. And so by default, what you can recognize are things like plane holes, countersink holes. But what if you've got a slightly more complex situation, maybe compound holes with 3 or 4 levels, as an example. So what you would do is you would program this just using the straightforward drill command to exactly the right specifications that you would want to do in the future. And what I mean by that is you might have do the chamfer, do the first diameter or the smallest diameter to full depth, and then you come with the larger diameter to the second depth, and then and so on. Select your tooling, select all of your, or modify all of your hole drilling parameters, and maybe your cycle definition as well, just to get it exactly how you want it. You then select all of those drilling operations, go ahead and give it a right click, and do Save Hole Template. This is off the top of my head, so apologies if the name was slightly wrong, but it's something like Save Hole Template. Save as Hole Template. Go ahead and give that a save. If you've got cloud libraries turned on, it's going to go ahead and save it to the cloud. If you've got cloud libraries turned off in your preferences, it's going to save it to your computer. And then in the future, what will happen is when you rerun the hole recognition process, it's going to look through those list of templates and recognize for the cylindrical surfaces that were used to define the hole in the first place. So if that matches what you've got saved in your templates, you can say, oh, you've got one of these holes already saved as a template. I'm going to automatically apply this option. And you have the option to change it if you choose to do so in the software as well. So it's as simple as program it how you want it using the simple drill command, select all the features or all the operations, right click, save as hole template, and then run your hole recognition and you're away. I hope that answered the question. Again, if it doesn't, hit us up in the chat. But, does that sound okay, chaps? Does that sound about right?
I haven't found the video yet. At this point, I'm doubting we have one. There's probably some written up material, probably a blog or something. But I think your answer pretty much covers most of what there was after. Well, just type thanks in the chat, so I'm assuming they answered the question. So great.
Maybe that's a good topic for a live stream, Rich.
Very off topic. We have another question, very off topic, but was curious to know if there would be an easier method in the future in Fusion 360 to delete the previous versions in a CAD assembly file that are not required anymore. No, there is
previous version.
I think it's referring to a loop that I've probably been stuck in multiple times when you try to delete something and it tells you it's referenced in something else and it doesn't tell you in what. Now, is that what the question is about? I can't say your name because it's anonymous attendee, but
if you let us know, if you give us a little bit more detail, that will try and. Oh, yes.
So, oh my days, yeah, I would love that right now because there's so many things that I would love to delete that sometimes I can't figure out where I used. It happens on drawings mostly, or it happens in components like vices or stuff like that you may have used in other projects. I know for a fact that they're looking at improving that behavior. I think they've already started working on it, so hopefully that's not going to be too long now.
But again, look, there's now another tally on someone.
Another little coin on top of it. So
yeah, all of this we do pass on. So please don't think that we're just saying we're working on it. but all this then gets passed on to people and the people that make the decisions. So that's why we are here. So one sec before I get on started, what about electromagnetic simulations in Fusion 360 for designing and simulating electric motors? That is well over my head.
Yeah, well, simulations for designing
I'll
electric motors for other electromagnetic applications. Well, that I know of, let me say I'm answering that I know of, we're not looking at that. I think we started going in maybe in that direction when we introduced the electronics functionality within Fusion. But when you start to get into electromagnetic, field, I don't mean an electromagnetic field, but let's say in the field of electromagnetism, then I think we're adding a lot more, let's say, topics that we can literally handle right now. But I mean, it'd be great. I can definitely pass that on. Again, if it's something that 200 people are interested in and we just don't know about, then the product management team has to look at it.
Yeah, we're here to fight your corners of what you want. So let us know.
A great question, Hans. I mean, it would be great, wouldn't it, to get into that sort of specialization in all fields.
Cool. So let's go for it again. But please, if you can give me a question, I don't have to present my slides, so I'd really appreciate it if you'll come up with some more questions. So finally, how can you basically use Fusion 360 as your design companion? So what I've got here is a component that we're going to make on our machine tool. We are going to use our machine tools to do some inspection, but then I need to inspect this on my CMM as well, so my coordinate measuring machine. It really annoys me when I see CMM fixtures made out of steel or aluminium. There is no force really put on a trigger probe of a CMM. It's not even measurable really with equipment you've got around. So you don't need a big, strong, sturdy fixture. What you do need is to hold the part nicely in the orientation you need. So if I was to lay that part, you can see there on the top right, flat on the bed, there's no way my probe head would be able to access it. That's why I want to jack it up a little bit, lift it off the table, and also put an angle on it so I can come in from behind and just machine the rear face as well. It's not good just to stand it bolt upright, because you're going to struggle to hold it bolt upright to start. But you think of putting it at 45 degrees, gravity is going to do 99% of the work on there, holding that part nice and securely down. So what you can do is use Fusion 360 to design this. So myself, I used to operate a CMM. I didn't have any access to designing of fixtures. So I had to go over to the design department, do a sketch on a scrap of paper to tell them what I wanted. Inevitably, it would be right, but wouldn't be quite what I was after. Do I bother going and ask them to design it again, or do I just have it made? But with Fusion 360, everyone has access to tools that would have been previously unavailable. So what you've got there is me as the CMM operative. If I've got a license of Fusion 360, I can design my own fixture. What I can do then, if you go back a slide, Spence, is I can actually look at 3D printing this. So what we can see in the bottom right there is Fusion 360's very own slicer. So this is connected to an Ultimaker printer I think I chose for that setup, and I can start 3D printing my CMM fixtures. So this is CMM fixtures, but if anyone out there has got 3D printers they're using with Fusion, hit us up in the chat. We'd love to hear about it. Cheers. Next slide, please, Spence. So what else can you do is hopefully everyone out there knows about the probing in Fusion 360. I never stop talking about it. So if you don't know about it, where have you been? But we have got some limitation in the reporting functionality of Fusion 360. But what we can do is use the Fusion 360 product to create the inspection sequence, run that on our machine tool, we can import the results file into Fusion, but we can also import that results file directly into PowerInspect and use PowerInspect's advanced reporting capabilities it's got. So you want to hop forward onto the video, Spence? So what we can see here is a quick video of this. So I've got my milling operations here. I've got all the normal toolpaths that I need to make this part. I'm going to go on inspect surface and I'm going to place some inspection points in the critical locations on this part. So it's a lovely demo to do. You just choose your tool, you click on a point, and then we dynamically put that point at what we call the surface normal. So this means you don't get any skidding because we're always approaching at that surface normal. So I'm going to put a load of points at segments across this mold tool, and it's going to hopefully check for me that my toolpath has worked, that I've got a nice mold tool that is all correct specification. So I've got all that in place. Now I'm going to put a couple of points in these holes as well, just to make sure that everything's well and good with those. And what I have to do now is I have to create the NC code, run this on our machine tool, and then our machine tool kicks me back a results file. So we're going to create the NC code here using NC programs. That's going to create the results file for me. And then I'm going to import that back into Fusion. So this is run on the machine. The machine has inspected the part. It's made a results file. And then this is the results file that we are loading back into Fusion 360. Spence, do you want to grab that question?
Yes, I do. I was just typing the answer. So the question from Elaine is, I logged in late, my apologies, but is the intent to integrate or include FeatureCAM into Fusion 360, or will it be kept as a separate product? So I'm going to say about 6 months ago, the products were aligned from a sales perspective into a single offering called Fusion 360 with FeatureCAM. Now, the idea behind this and the intent behind this was to offer more value, not only for the current FeatureCAM users, because now they get access to significantly more software, but also to give value for any new users who want to purchase an offering that combines, like we said, these series of product offerings. Now, these products are separate. They are not embedded together. So when you, or if you purchase a Fusion 360 with FeatureCAM offering, you will get access to both of these products as separate offerings. And so, yes, they are combined in terms of a sales perspective, but no, they are very much separate products. You will see some functionality similarities and new additions to Fusion that you might recognize from FeatureCAM. The idea behind that is to align our development focus. And so moving forward now, if something gets improved, let's say on the Fusion side, in terms of the whole recognition, it doesn't just benefit Fusion, it's also going to benefit Fusion and FeatureCAM. And so that's why some of the technology is being brought across, is to align on development focus. I hope that answers the question. As always, if it doesn't, the chat box, please. Back to you, Rich.
Cool. Oh, 1 second. Spencer, what are the chances of England taking the Ashes this year, as they're going to stay at home where they belong? Go Australia. To be honest, yeah, I don't want to get into a debate really on this webinar, but we'll just see what happens. You know, let's let things play out before we start assuming where things are going to go home or not.
Or you could be Italian and know very little about cricket.
Or any decent sport for that matter.
Mate, 4 stars on the jersey. Never forget when it comes to football. 4 stars.
How many rugby ones have you got?
Doesn't matter, does it?
I'm going to say go England, because we've got 1 minute left, Rich.
Yeah. What you can see there very quickly, we've got the inspection results back into Fusion. So that is what we've got there. We've got a really nice table to show us the deviation of those points. So, we've probed it on the machine, we've got the deviation back, we can see it in a table. We can also export this into a PDF report. So we can export this into a 2D PDF. But unfortunately, that PDF is pretty static. We can't do much in the way of editing that PDF. But what we could do is bring this back into PowerInspect and utilize all of PowerInspect's advanced reporting capabilities as well. So again, slightly run out of time for that, but anyone that wants to know anything more about any of these topics we've covered, please give us a shout. Mainly on the forums is probably the easiest way to speak to us. Put the questions up there and we'll do our best to contact you all.
We cannot hear you, Spence.
Spence, we can't hear you.
Perfect. As always, I was on mute. So with that, thank you very much to everyone that joined. Special shout out to everybody that asked questions. And I guess all that's left to say from myself, from Richard, from Paolo, thank you very much.
Thank you everyone for joining.
Thanks very much. And please speak to us all as much as you can. Forums, watch our YouTube lives that we do most Thursdays. Log in and you'll watch me, Spencer and Paolo take the mick out of each other for a good hour. So,
and sometimes fail with technology.
Oh God, that Steep and Shallow one was pretty epic.
Steep and Shallow V1. Yeah, thanks everyone, guys. Thanks for your time today. Thanks for your questions.
Thank you.